Hey guys, today we're going to look at the pH of a couple different salt solutions. And the purpose or the goal of this part 3 of our acid-based salt pH lab is to investigate the effect that a cation or perhaps anion has on the pH of a solution, right? So its ability to generate either hydronium or perhaps hydroxide. Or we'll investigate that some of these salts actually really have no bearing on the pH. Okay, so what essentially we're going to do is fill out the data table for part 3 of this lab together. The first data point we're going to take is that of water. Now what I have here is distilled water. I take my pH paper and I test the pH. What we identify is that it has a pH somewhere between kind of 5 and 6. It's really common for distilled water to have a pH of about 5.8. The reason behind that is because carbon dioxide gas readily dissolves in water, creating carbonic acid. So we're actually going to see that it's slightly acidic. So all these solutions will have to kind of, evaluate with that in mind. So really what we're doing is we're using that pH of water, we'll call it 5.8, as kind of a baseline, right? And we'll see how these solutions kind of deviate and become acidic or perhaps basic in nature, okay? So the first solution we're going to take a look at is that of ammonium oxalate. So I have ammonium oxalate here in the beaker. We'll take a look. What I find is that it's, I don't know, I'd argue about a 6 to 7 there, about a 6 to 7, okay? Next up, we have aluminum chloride. So again, the goal is really to figure out, based on the data, is it the aluminum or is it perhaps the chloride that's really causing this, dramatic shift in pH? We find this is quite acidic, maybe ringing in about a pH of 2. We push on to aluminum nitrate, okay? So what we've done is we've exchanged chloride with our nitrate. So we still have aluminum, which may be a suggestion of kind of what's going on here. Again, identify that aluminum nitrate is a pH of about 2. I push on to sodium nitrate. We should know from our solubility rules that both sodium and nitrate are soluble with pretty much everything. And when I say pretty much, I mean everything. So it'll be interesting to see what happens here. Okay. Now again, we can talk about this a couple ways. We could say that it's maybe this pH between 5 and 6, which again, recall that that's what our kind of baseline, that's what our control of just our distilled, ungassed water looked like. Keep that in mind for sodium nitrate. We push on to ammonium thiocyanate, our NH4SCN. Let's take a look at that. Okay. I don't know. Again, somewhere between kind of 5 and 6 there. Kind of tough to tell. Actually, maybe creeping down towards 4. Maybe creeping down towards 4 there a little bit. Okay, but again, tough to tell. Maybe in that 5 to 6 region. Up next, we have our ferric nitrate. So again, nitrate, pretty soluble with just about everything. But we do have the presence of the transition metal there, the iron. Okay, now again, the color of the solution, if you were catching that, is orange, but the pH paper has become this dark red. Wow, this is actually quite acidic. I'd argue maybe between 1 and 2 there. Okay. Next, we'll take a look at zinc nitrate. Again, we got zinc, another transition metal. Okay, so perhaps we're starting to kind of develop a trend here. Maybe. This looks like maybe it's a pH of about, maybe about 3 or so. We'll push on and get to our sodium acetate. Okay. Looks to be about a pH 7, which again would suggest neutrality, right? But you got to keep in mind that our tap water in the first place was slightly acidic. So this has apparently increased the basicity of that solution. Okay. We have our potassium chloride up next, so our KCl. Kind of a cool hue to that solution. Let's take a look. It's looking to be about, in between maybe like a 5 and a 6 there. And last, but to not least, I suppose. We got ammonium chloride. And this is looking maybe somewhere in that 4 to 5-ish region. Kind of tough to tell. Somewhere between 4 and 5. Okay. All right, and that'll be the data for part 3 of the acid-base salt pH lab. Thanks, guys.